Okay, it says to identify the minimum value of the given function. And what I would like to see here, I mean, we wish there was some grids or line, it was numbered, but it's not numbered. I guess we can presume this is one. But the minimum is over here. The question is, well, is it asking for the X or the Y? This is interpreted as what is the minimum, not where is the minimum. Okay, so what is the min is the Y value. If it asked where is the min, that is the X value. All right, so we want the Y value here. 1, 2, 3, 4, 5, 6. Looks like it is -6.
For the minimum?
Yes.
Okay. Okay.
So do you want us to go left, right, or vertically?
It does not matter.
Okay. Doesn't matter to me either. These are all the same in terms of
So
interest.
we can just go down.
Okay. All right. All right. A spherical balloon is filled with a gas at a rate of 12 cubic feet per minute. What is the formula for the volume of a sphere?
4/3 pi r cubed.
Yes, very good. It's filled with a gas at a rate of 12 cubic feet per minute. The units tell you which one it's for. Because it's cubic feet per minute, that's V prime. Because cubic feet is volume, per minute is a rate, that's V prime. We want to find the rate of change of its surface area. So we really want A prime. That's what we're trying to solve for. Okay, which is dA dt. That's down here. That's that. When the radius is 5 feet long. So I like to actually identify all the stuff that they're giving you and then figure out where to go from there. Do you remember how surface area is related to volume in calculus?
Isn't there a formula?
So surface area is the derivative of volume. In your previous classes, you were given that formula. It was like surface area is 4 pi r squared. Now you know why. It's because it's the derivative of volume.
Only for sphere or for everything?
Everything.
Oh, I don't think our teacher ever told us that.
All right. Well, the thing is here is like there's more to do than that. Unfortunately, there's quite a bit here. The A prime is referencing the area. So you have to take the derivative of this. A prime is 8 pi r prime.
Okay.
All right. Problem is you don't have r prime, but you do have r. That's good. So how would we find r prime? R prime comes from V prime. So a little error in V prime. There's also an R prime here, or dr dt, because of the implicit derivative of r. So the reason that's needed is that allows you to find r prime. Your V prime is 12. Your r is 5 squared, so you can calculate r prime on the right here. So we're looking at this equation. A couple ways to do it. You end up getting 12 over 4 pi over 25 equals r prime. So r prime is 3 over 25 pi. And that goes over here on the right. So it's 8 pi 5, 3 over 25 pi. The reason you don't go to a calculator is because stuff cancels. You got 5 and 5 cancels, pi's cancel. So it looks like it's 24 over 5 as your units there.
Okay.
I guess you do have some numerical. Yeah, or some there, but it is there. It's on the second page.
Wait, 24/5.
Yes.
Okay.
But maybe more important than that is like, just working through the progressions here of like, well, yeah, it's volume, but you're not even like normally you're just finding like V prime or R prime. You have to find R prime to put in A prime. A lot going on here. Any follow up to this? Any other thoughts?
No, that works.
Okay.
Okay.
All right. Conical pile of sand. All right, a conical pile of sand, so that's a cone, is being added to at a rate of 15 cubic yards per hour. That's your V prime. Again, because it's cubic yards, that's volume per hour, the rate. The sand is piling in such a way that the diameter of the pile is always twice the height. So they're saying D equals 2H. Find the rate of change of the height. So they want H prime. That's what we're trying to determine. When the pile is 6 feet high. I guess that's feet. Okay. That's odd. It says find the rate of change the height, but this is dv dt, which is 15. But this must be an error. I'm sure this is dh dt because the units are cubic feet per hour. It does say height. We're looking for that. I don't know. Did you get any like corrections on this, or is this everything you
I
got?
don't think so.
Okay. All right. So volume of a cone. Volume of a cone is 1/3 pi r squared h. And if you draw a cone kind of from its side, here's h. The diameter is this. The diameter is really 2h though, according to this information. So if you cut it in half, the radius is h. The radius of the cone is, because it's really like a circle. So the radius is h according to this. Does that
Yeah.
okay? So the volume is really 1/3 pi h squared times h, or 1/3 pi h cubed. You generally always want to reduce ahead of time. Okay, so now your derivative of this v prime is power rule. So it's 1/3 times 3 pi h squared h prime. Is that okay for that?
1/3 2 times 3.
Yeah, for the power rule, because it's h cubed, 3
So why
comes
don't you
down.
just simplify to 1?
Well, because I'm trying to show you the steps. I mean, I could answer this problem without
Oh,
doing
okay.
any of this, but I thought it might help for you to see that. So do you want me to show you the work or?
No, I did.
Okay. All right. So do you have V prime?
Um, is it given in the question?
I don't know. Let's go take a look.
The rate of, so isn't 15 it?
Sure looks like it. It also appears that I wrote it down. So I actually wrote down V prime as 15. Maybe you missed that. Not sure. Okay. Do you have H?
Yes.
Okay. Do you have H prime?
No, that's what we're
Nope.
solving for.
Exactly. So you've got everything though you need to solve for H prime. Why don't you go ahead and calculate that for us, please?
Okay, so 15 equals pi. So is it 5/12 pi?
So you've got, like you said, it's 15 equals pi 6 squared H prime. So H prime is 15 over 36 pi, which divide by 3, 5 over 12 pi. Now the question is like, is that, is that going to be in another, is it that way or is it as a decimal? Got to guess, we got to go take a look here. And
Yeah, that option's not. Oh, wait, 3? No. I don't think
so
that option is.
so
Yeah.
let's also use a calculator here and just see if that one is also there. That's the problem with these sort of when you're going back and forth between these things here. So I see 3 over 25 pi,
Yeah.
which feels like that's what this should be. Is it, so the only thing that I guess I wasn't sure of is this, if this is 6, okay, I see the error here. So this is in feet, 15 is in cubic yards per hour.
Oh.
So we've got to convert from yards to feet. So that changes 15 to, if you want 15 yards times in 1 yard, there's 3 feet. So that will change this to, I guess, but that's cubic yards. So they wanted in cubic feet per hour. Okay, so we gotta do the unit conversion here, unfortunately. Okay, so it does come from this 15 yards cubed per hour times 1 yard is 3 feet. So we have to cube both of those. That's 15 times 27, which we'll leave. That's okay. And then put that here, 15 times 27. So what that does is the 27 and the 36, they reduce by 9. So you get 15 times 3 over 4, which is 45 over 4 pi, which we're still not seeing.
Did you put it in the calculator? Should I put it in the calculator?
Yeah, go ahead and try that. It really feels like it's this other one. Maybe there's another conversion. This six could also be an issue because it might be 6. I don't know what that unit is. 6 tick means
It's like 3.58.
feet. That is feet. Diameter is always twice the height.
Oh, wait. No, yeah, that's an option choice.
45 over 4 pi.
No, wait, that doesn't make sense. That doesn't make Oh, no, that makes sense. That makes sense.
Okay.
It's 3.5809.
Yeah, I guess that's so this one is converted back to that.
Yeah.
All right. So we'll keep going down the left column here. All right. So y equals cube root of x. The derivative is 1/3 x to the minus 2/3 dx dt.
Mhm.
They give you dy dt, which is what y prime is. That's 1/4. They give you x, that's 2. So you in principle here have enough to find dx dt. Probably more of an issue of sort of like being comfortable manipulating exponents and stuff like that. You can cancel the 1/3 by multiplying by 3, so that's 3/4. 2 to the power of minus 2/3. Again, that's 1/2 to the 2/3. That's the cube root of 2 squared. So that's the cube root of 4. So you can also clear that by multiplying both sides. So 3/4 times the cube root of 4. If this were an AP exam, they might go a bit further. They might leave it as 3 cube root of 4/4. That might be how they show it. Not sure, a little bit of a guess there. This appears to be another one of those ones you've got to go to the calculator for.
Yeah, wait 1 second. I'm still writing it all down. And then wait. Oh, no, I get it. I don't have my calculator on me.
All right, so let me send over a link to the Desmos Scientific. One of the nice things about this calculator, and I'm not affiliated with them in any way, but you can enter it essentially the way that it's written, which really helps. You don't have to sort of worry about where parentheses go. I'll show you that here. So 3, 4, and then you can go.
Oh wait, I got it. It's
Pretty nice. You can actually enter it exactly the way you see and get the result there. Any questions on this or anything you'd like me to clarify?
I don't see the answer on the option choices.
Okay. What is your result for this here?
So it says that equals. Oh wait, I think I typed it in wrong. Yeah, it's 1.1. Yeah, that's an option choice.
All right. Okay. Should we go up to the right column now or onto
Sure.
the second page? Okay.
Sure.
Here we go. So another spherical situation. Spherical balloon is filled with a gas at a rate of 12 cubic feet per minute. V prime is 12, and it comes from the units. Really good to know that. The rate of change of its surface area, A prime, that's what we want to find. That's wow. So they again, there's a problem here. The units for this don't match the units for area, surface area. Surface area prime units would be like feet squared per minute. dr dt is the change of the radius, which we can find. There's some sort of error here is what I'm trying to say. So we can find r prime. That's kind of an intermediate step here, but when it says find the rate of change of its surface area, like, I don't know what to do with that because that doesn't appear to be synced up with this. Nevertheless, volume is 4/3 pi r cubed. V prime is 4 pi r squared r prime. And just to be clear again, V prime is dv dt, r prime is dr dt. Okay, so we have everything to solve for r prime. R prime is V prime over 4 pi r squared. So r prime is 12 over 4 pi times 5 squared, like that.
Okay.
So that is 3 over 25 pi.
And I believe that's an option choice.
So if we were to find the surface area prime here, we'd start by knowing that, okay, we need the surface area formula. Surface area is V prime, 4 pi r squared. A prime would be 8 pi r prime. It feels like we did this already. We actually did this already. So I think the issue here is they just copied and pasted something wrong. Okay. Yeah, I mean, this is the same as the second one we did. It's just this one has the error. Shouldn't be asking for that. Should be asking for the rate of change of its radius. Or there's an error number, the second one we did, I don't know. All right. Okay, so this next one here on the right, let me know when you're ready for that.
Yeah, I'm ready.
Okay. Okay, find both critical numbers. Okay, identify the leftmost one. So we assume that's the one that's smaller, would be a better word choice than leftmost. What is a critical number? What does that actually mean?
When the derivative equals 0.
That's right. Derivative equals 0. Can you calculate the derivative of this one for us, please?
Yes. Is the critical numbers -5 and +1?
I don't know because I was waiting for you to give me the derivative.
Oh, the derivative would be 3x squared plus 12x minus 15.
Okay, and then your next step here is to factor. How did you approach factoring this?
I made it equal to 0.
Okay. And in terms of factoring, there's a number of factoring types here. What do you see? What would be the optimal way to begin?
I just factored out the 3.
Yes, and that's very important that you did that. The GCF, you'll see it on these types of tests. it will save you a ton of time. X plus 5, x minus 1 equals 0. Your two critical numbers are -5 and +1. I think you said that. The leftmost one is -5.
Okay. Wait. And that's an option choice. Okay, moving on.
Okay, so the mean value theorem, kind of a pretty neat thing here. The mean value theorem says that between 2 points, and they don't have to be different in height, but they typically are shown this way, there's a secant line. We don't know what the actual curve does. It could actually do a lot of things, but the idea is that there's a tangent line parallel to the secant line, or they have the same slope. Okay, now that's the shorthand description of it. You do need to know the following. You need to know that f prime of c, and that's what you're trying to determine. There's some place where you evaluate the derivative where its slope, that's what f prime of c is, equals the slope of the secant line, f of b minus f of a over b minus a. Okay, so part one of this is to get the secant slope. That's the thing on the right here, the average rate of change. You are given an a and a b. Will you calculate the f of b minus f of a over b minus a for us?
Okay. So like, oh wait, I get it. Never mind. Okay, so I got the answer to be 20.
Yes, 43 minus 3 over 2 minus 0 is 20. Awesome. The next part two, is the derivative. Okay, so you want to take the derivative of this 24x minus 3x squared, and you set that equal to the number you just found. All right, and then you solve that equation. So you solve 24x minus 3x squared equals 20. I'd recommend reordering this a little bit. 3x squared plus 24x minus 20 equals 0. This one is not as easy to factor. It is doable though, but it's not great. Are these by hand or calculator? Do you know?
I don't know.
Okay, because if you were allowed to use a calculator, I would tell you to graph it, do something else. You want the I mean, you just want the answer. You don't care how you get it. In terms of factoring it, you got to do the -3 times -20, which is 60. Two numbers that multiply to 60 but add to 24, if that exists, may not. But that's kind of the direction you're going here with this.
So the answer would be 60.
No, that's the type of factoring you would do here. So because it's the leading term isn't 1, you can't just find two numbers that multiply to 20. it's this grouping type of factoring. So that's why I'm asked about if you can use a calculator or not, because if this one doesn't have nice roots, you're forced into using quadratic formula or calculator or something else.
Okay, then 3x squared plus 24.
I mean, to me, you're allowed to use a calculator because a few of the problems have been estimated. You know, we've estimated the value using the calculator. So should we just go to a graph and
I can just plug it into my calculator.
okay?
Okay, so the answer would be 0.9445.
So yeah, there's actually two answers, right? There's 0.945 and 7.055. The problem is like they're not both correct. They have to be in this interval. So only one of them is correct. This first one is the one you would want. There could be more than one answer that's in the interval, but probably not on what you're doing in the AP, but in real life there could be. Any questions on the mean value theorem?
I think I get it.
There's the related one, Rolle's theorem. It's we'll see if it comes up. I don't know. You don't need to know the theorems. You need to know how to do the calculations, you know. All right. A particle is moving along the given curve with dy dt equals -6, x squared plus y squared equals 25. Find dx dt when x equals 3 and y equals 4. So whenever you see both an x and a y, you want to think implicit derivative. Do you want to try finding the derivative here of this?
Okay. X squared. So 2x plus 2y prime equals 0.
Normally that would be correct because it's saying x is defined implicitly as well. X is a function of t and y is a function of t. It's x prime plus 2y, y prime equals 0. And you would have figured that eventually because you're solving for dx dt. So you'd be like, oh wait, where's the thing I'm solving for? So x prime here is -2y, y prime over 2x, or minus y, y prime over x. All right, so that's -4 times -6 over +3.
So the answer would be -4 times -6 equals -24 over 3 equals +8. Okay.
All right, so we're down to our last 10, 11 minutes here. Is there any, do you want to look at this and see if there's any particular ones that you want us to do, or just keep going in order?
We can just keep going.
All right. Okay, on the interval -5, 4, identify the value of x where the absolute maximum occurs. So there is a recipe for this. The steps are to first evaluate the endpoints. So find f of -5, f of 4. You want to leave a little space because you're going to evaluate more places, but this has to be done first. This has to be done with a calculator. So go ahead and grab your calculator. And the fastest way to do this would probably be to put this into Y1 and then do a table, set table ask. No, you don't have your calculator, but that would be the fastest way to do it, because then you don't have to put them in each time. You might make a mistake. Lots of things can happen there. Or you can go to the calculator, graph it, and do the calculate the value.
Okay.
All right,
So it again just mean value though.
this is not the mean value theorem. This is extreme value theorem,
Oh,
which requires you to evaluate the endpoints and then any critical values in between. It's a small difference, but it is important here.
is there any quick way to do it? Or is it just this? Or I know you said the calculator.
Yeah, I
like-
mean that's it. There's no shortcut here. I'd recommend having the calculator during our lessons. That way you get some practice with using it. I've got a virtual TI-83. I can pull up and show you how to do some things if you're interested. Do you have some numbers for me?
I'm solving for f of 4 now.
Okay.
For f of -5, I don't know if mine's correct. I got negative 3,555.
So I got different number, got these two numbers. I mean, I guess it's possible I made a mistake here as well. So let me take a look at my calculations. X squared plus 384x minus 110. Looking pretty good here. Let me check it with the
For f of
graph.
4, I got 146.
Okay, so we'll assume we'll go with my values here. I'll double check those in a moment here, but that's only the first part. The next part is to take the derivative. So derivative of this is 12x cubed minus 24x squared minus 192x plus 384, like that. You have to figure out where this equals 0. And unless you've magically figured out how to factor cubics, which is quite difficult, most people don't know how to do that, and it's not even taught anymore. You have to probably use a calculator to see where this equals 0. So you do not have a calculator. So if you don't, maybe go to Desmos and graph this. Let me I'll double check these values and then I'll get these as well for you.
I have like the calculator on my phone, so I can like plug that in.
Yeah, I mean that's like I don't know, like walking to school when you got a car. You don't want to do that. That's gonna be not be good. You seem to have the right value. Oh, that's x plus 110. That's why it's off. 3x to the fourth, 8x cubed, 96. Squared plus 384x minus 110. All right. All right, so I can confirm these are correct from the graph. The zeros here for this are at
2, -4, and 4.
that sounds right. They're nice, which is shocking. It's like, wow, they're nice. So this is -4, 2, and 4. Are any of these in this interval from -5 to 4?
2 of them are.
They're all there. The 4 is in the interval, but we've already calculated that. So you also have to calculate f of -4 and f of 2. So this is again why having the calculator there, you could just go to table ask or go to the graph and get them. Will save you a ton of time here.
Okay.
So if you have that, if you have you quickly can graph it here or use the calculator, doesn't matter. -4 though appears to be minus 1902. And f of 2, get that one there. 258, maybe.
And then you still plug in 4, right?
You've already got 4 from the original.
Oh, yeah.
And you put the critical values back into the original.
So it would be x equals 2.
So we're looking for the absolute max. So the
Yeah.
absolute max, you look at these 4 values, what's the biggest one? That is the absolute max. If it were looking for the absolute min, it would be this other one. It could ask for relative min max as well. That would be something else that you might see. All right, let's see if we can quickly talk about another one. All right, so 24. We'll get as far as we can get on this. None of these are really short, unfortunately. All right, so you got to find the derivative, f prime of x. Derivative of cosine is minus sine. -3 sine 4/3 x. Chain rule, multiply by 4/3 plus 2. So you get -4 sine 4/3 x plus 2 equals 0. So to find the critical numbers, you set this equal to 0. So it involves a little bit of your trigger view. One of the things you can do here, and that's what I'll do this real quick, is you can actually graph it. And if you're comfortable with your calculator graphing, this will save you a ton of time, especially if you restrict the window to the period that it's talking about.
Mm-hmm.
And I'll show you that here. All right. All right, so if you get comfortable with graphing, I mean, I know you don't have this, but your calculator will do essentially the same thing. This is the derivative, and you find those places. They will sync up with a place on the multiple choice. The first one is pi over 8. The second one is 5 pi over 8. It wants the leftmost one. So there you have it.
Okay.
All right, we're going to go ahead and stop.